Hi, math students. It's Miss Carol again, and we are back for the Unit 3 project, and this time we're on Lesson 13. And we are going to use the properties of exponents as shortcuts to answer the questions about plant and animal life in the same part that we were dealing with earlier. So they have a little reminder here that we can use the product of powers rule, the quotient rule, or the power of powers rule to answer these three questions. Okay, so first question says, a map of the park can be divided into a grid of 9 squared, or 81, equal sections of land. It is estimated that there are 9 to the 6th ants per section of land. That's crazy. Write the total number of ants in the park as a power. Okay, so when we're thinking about this, and I have, there we go, lost my pen. Let's go ahead and let's just imagine that let's imagine our grid, okay? And so that gives me 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the same way. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so in every single one of these squares, we have got 9 to the 6th, 9 to the 6th ants, okay? So the way we can do this is to use the product of powers rule. So basically, I know that I've got 9 squared squares, or 81 squares, and I know that in each of them there are 9 to the 6th ants. Okay, so I can now multiply 9 squared by 9 to the 6th. And the product of powers rule says that when I have the same base, okay, 9 squared times 9 to the 6th, then I can keep that base, but add the exponents, all right? Essentially what's going on here is that I've got 9 squared, which is 9 times 9, and I've got 9 to the 6th, which is 9 times 9 times 9 times 9 times 9 times 9. All right, so now suddenly I have 1, 2, 3, 4, 5, 6, 7, 8 nines. I have 8 nines, which is 9 to the 2 plus 6, or 9 to the 8th power. So this explanation, I think, right here is the best for why adding exponents works for the power, or the product of powers rule, okay? So 9 to the 8th, and let me just do that real quick. That is 43,046,721 ants in this one park. But we're going to write it as an exponent, thankfully. And it was 9 to the 8th power. And that's all you need to write. Okay, next question. Wisteria is a blooming vine that grows in many parts of the park. And if you live in Boise, you will have smelled wisteria. It's delightful. Wisteria is a blooming vine that grows in many parts of the park. The maintenance crew cleans up a total of 6 to the 8th of the tiny wisteria flowers annually. Each plant drops 6 to the 5th flowers annually. How many wisteria plants does the park have? Okay, so each plant drops that many flowers, and so we know the total number of flowers, and we know the total number of flowers dropped per plant. So let's think of this kind of like a unit question. What we're trying to figure out is number of plants, right? We want number of plants. Okay, and we have 6 to the 8th flowers. All right, and we have 6 to the 5th flowers per plant. Okay, this right here, plant, is what we want to have in the numerator. Okay, so if I were to divide 6 to the 8th flowers by 6 to the 5th flowers per plant, okay, my flowers would cancel out and my plant would go, see it's in the denominator here, and it would flip around to the numerator and I'd be left with plants. Okay? So let's go ahead and do that operation. We're going to divide 6 to the 8th by 6 to the 5th. And this, if we write this out the long way, 6, 6, 6, 6, 6, 6, 6, 6. Okay, so this is 6 to the 8th. Okay, and then we've got 6, 6, 6, 6, 6. Okay, this is 6 to the 5th. All right. Fortunately for us, we can see that these are all going to go to 1, and we're going to be left with 6 times 6 times 6, which is 6 to the 3rd plants. Okay? Now, the easier way to do this is to say that when we're dividing and we have the same base, we can simply subtract the exponents. So this is 6 to the 8 minus 5, which is 6 to the 3rd. Okay, we get it the same way, but this is why that works. Okay, very, very similar to multiplication, except we're doing it the other way around where we're subtracting. The quotient property is the opposite of the product of powers property. Okay, so in this one, we simply need to write 6 to the 3rd power. Okay? Okay, last question. In the first question for this part of the project, the number of ants per park section was given by 9 to the 6th power. However, 9 is a perfect square that's equal to 3 squared. Explain how to rewrite 9 to the 6th with a base of 3 as a single exponent. And then we need to identify which property of exponents we use to do that. So if we know that 9 is 3 squared, then we're just going to substitute that into that 9 to the 6th, all right? We're going to replace 9 with 3 squared, but we're still taking it to the 6th power, all right? And hopefully you'll recall from this lesson that when you have an exponent taken to a power, you can multiply these two numbers. All right, so this is essentially going to be 3 to the 12th, but let's really think about why that works, okay? So if I have 3 squared to the 6th, that means that I have 3 squared times 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 3 squared, right? So that's 3 squared to the 6th power, 6 of those. All right, so this then becomes 3 times 3, and this is 3 times 3. Each one of these is 3 times 3. All right, and if we count those up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is why that works. Now, this is a manageable number. It still kind of took me a while. It's a manageable number to work with. But imagine if we had 3 to the 4th to the 27th. That would take us forever to do. So we know then that we have a little shortcut, which is the power of a power property of exponents that says that if we have a base taken to a power that is then raised to another power, we can multiply those two values. And essentially, it's an extension of the power of products, but we call it the power of a power. Okay? So, the first question there asks us to explain, let me get my cursor in here, explain how to rewrite 9 to the 6th with a base of 3 as a single exponent. So that will be, let's just show it. We'll do 3 squared to the 6th power equals 3 to the 12th power, okay? And then the second question says, identify which property of exponents is used. So I've said it many times, but just to be clear, this is the power of a power of powers. Let me just make sure that that's the exact term that they're looking for. Power of powers rule. Okay. So hopefully that was a helpful exercise for you, and that's all you need to do for lesson 13. I will see you back here for lesson 14. Thank you so much for joining me.